name is Dmitry Schigel. I'm a scientific officer in the GBIF Secretariat, and I'm leading the work package 4 on data use cases and data streams together with Doug Anderson in the BioDT project. The use case on phylogenetic diversity is actually very special. There are two main ways to understand and detect biodiversity on the planet, both statically as patterns and dynamically as processes, is to figure out which species occur in a particular space and time period, and then to quantify it, to see what species is dominating, which species is rare, and how these patterns are changing over time. Phylogenetic diversity use case is very special. It's going deeper and looking at the biodiversity on the planet from the evolutionary perspective. And that is maybe not very straightforward to understand, but it's a very important evolutionary consideration and a different viewpoint on the same time and space envelope, because every single piece of land populated with life can have a different phylogenetic tree of relatedness of organisms to each other, evolutionary speaking. And some places can be very species rich with very interesting dominant structures, but very boring from the phylogenetic perspective, whereas others can be less diverse in the classical sense, with lower number of species, maybe uninteresting dominance structure, but from the phylogenetic perspective, from the evolutionary diversity perspective, such spots are unique. So from that point of view, it's very important that in the portfolio of the use cases and the Biodiversity Digital Twin prototypes, we take into account also that evolutionary perspective for land use decisions, for conservation related matters, and so on. Yes. So building on that evolutionary logic, this Biodiversity Digital Twin on phylogenetic diversity relies on two independent data streams. One is the availability of the point occurrence data of where species are in time and space, and that part relies on infrastructure of the Global Biodiversity Information Facility of GBIF, which is well established. It has an online portal, it has the API protocol for machine-to-machine data use, and the other component is Open Tree of Life or any other user-provided phylogenetic tree, which gives you a map of relationships for these point occurrences. So you have spatial temporal component from GBIF, and you have phylogenetic and evolutionary component from Open Tree of Life. The challenge here is that the dynamics of this data is different. GBIF-mediated data is growing very rapidly, is changing and growing very fast. Our understanding of the phylogenies, how species are related to each other and how they were diverging is not growing as fast. So you have two dynamic data sets developing in different speeds. So it's a very interesting challenge scientifically, but also computationally from the computer sciences perspective, is to put these two very different ingredients in the single use case prototype, in the single twin prototype, which can then be put on the supercomputer, and we can see if that can help us to speed it up. Because the pipeline, which we have already available, is very hungry for computational resources. So to do things like, if you want to model phylogenetic diversity of all mammals of Brazil, for example, you'll need a lot of computational power, a lot of time, and the whole idea of building biodiversity data twins, whole idea of building biodiversity twins is to speed up the process and to parallelize them and to utilize the available supercomputer resources. I think placing phylogenetic thinking into the decision-making space, into the policy space, is a very interesting challenge. A lot of decision-making and land use decision-making still now relies heavily on human expertise, increasingly on more and more on data systems, but very often it's regulated through legislation. Please tell us who is there and how many of them are there, and then the decision is made. Phylogenetic is doing it differently. It takes into account evolutionary relationships, and bringing this approach, this way of thinking, to the stakeholders who are doing local land management or conservation is a very interesting task. We cannot really predict the reactions, how ready the communities will be to that, but I think that what makes it real interesting. It's not like, just another digital toy coming or another database or report. This is something that very likely such stakeholders have never seen before. But people are generally familiar with the concept of relatedness. Humans in general are interested in things like genealogy and the origins of their families and so on. So even for non-biology stakeholders and for general public, explaining this, the idea of phylogenetic diversity is actually an approachable task. There are several levels of answer to this question. One is that we are testing the limits of technology. We're testing the limits of complexity, how big, how heavy can be models that our current technology allows us to calculate, to compute. Will it take months or years or weeks or maybe hours or seconds? And we have to try with the use cases of different complexity. Another aspect related to this is that modeling in general has been living in kind of academia-heavy environment where the main output of your work is a publication. There is an interesting question, you match it to the data and a hypothesis, you answer it through modeling maybe, there is a model which maybe is very popular and it lives beyond publication, but very often every modeling exercise ends in a paper as the final point, as the end game, which doesn't really help anybody but the authors of this paper to boost their academic careers. And digital twin, the philosophy of this project and the brave idea of this project is to break this culture of single-use coffee cups models and to put together dynamic and parallel modeling systems and make them broadly and dynamically available also beyond the project.